right, good morning. We're going to go ahead and continue practicing graphing systems of inequalities, except today I want to look at some unusual cases. All right, so let's get started. Before we jump into the weird cases, let's kind of do a little warm up here. So you guys try this one. All right, let's see. So we're going to start at 1, go up 2 over 1, and go and just connect it. Test the point 0, 0. Yep, let's not do that. All right, before we get started, let's do one that you should be pretty familiar with in terms of being able to do, kind of like our warm-up, all right? So let's go y is less than or equal to negative x plus 1, and y is greater than 2x minus 3. All right, I'm going to call this equation 1 equation 2. So we're going to start equation 1. I'm going to start at 1. Go down 1 over 1, and then we have some line going like this. Let's test 0, 0 in equation 1. So is 0 less than or equal to 1? That is true. So I'm going to shade going down this way. Let's do number 2. Start at negative 3. And I'm going to go up 2 over 1, up 2 over 1. I'm going to test 0, 0 again in this one. So is 0 greater than or equal to negative 3? That is true. So true is over here, so I'm going to shade this way. So you got to keep track of the point that you tested. All right. So this is the region I shaded that overlap. Therefore, my solutions are in that yellow region. All right. And remember, this plane goes on forever and ever, so this region is gigantic. All right, let's try one that's kind of like that, except I'm going to change the form of the equation. We're going to go x plus y less than or equal to 4, 2x minus y less than or equal to 6. So there are some strategies in graphing this. I can solve for y and graph the line and then test my points. I'm going to use x and y intercepts to graph my line. So for number 1, I'm just going to make a quick table of points. So I'm going to plug in 0 for x. If I plug 0 in for x, y is equal to 4, right? Because the 0, that goes away. Okay, I'm also going to use y equals 0, so I'm going to just plug in 0 for y and solve. You can just see it, x is 4. So I'm going to go ahead and plot those points. And then connect them. And then I'm going to still test a point. I'm going to test 0, 0. So 0 plus 0, I'm asking myself, is that less than 4? Is 0 less than 4? That is true. So I'm going to shade in this direction. All right, now I've got to go to line 2 and do the same process again. I got to graph my line. I'm going to make a table. I'm going to plug 0 in for x first. So I got negative y equals 6. I got to divide both sides by negative 1. Right? And then I'm going to plug 0 in for y. We're going to go equals 6 because I'm just trying to find the point. So 2x equals 6 or x equals 3. So 1, 2, 3, and 1, 2, 3, 4, 5, 6. I got to test the point 0, 0. So 0 is 0 less than or equals 6. That is true. This is true over here. Remember, this was the line number 2 that I graphed. And there we go. So this is the region. Got to kind of keep track of where my lines are. This is the region where they overlap. So that is my solution. No different than what you've done previously in terms of the idea of where your solution is. It's just the way, the form of the equation, this is in standard form, so I made a table. Whereas this was in slope-intercept form, so it was easy for me to find just the y-intercept and then move based on the slope. All right. So now, I want you to tell me, where do you think my solutions are? Do you think it's in region 1, 2, 3, or 4? Yeah, hopefully you said 2 because that's where both lines overlap, right? Both regions overlap. So this got shaded down, this got shaded up. Therefore, this is the region where all my solutions are. How about this one? Where do you think my solutions are? That was a trick question. So if you look at the shading, this is shaded down, this is shaded up. Do they overlap? No. If they don't overlap, then there's no regions, there's no points they have in common. So in other words, this would be no solution. No points will satisfy both equations or both inequalities. So in this one, equation A, it'll be true on this side. Equation B will be true on this side. In this middle region, nothing's true. So none of these points will work in either inequality. All right, what about this one? So just to make sure you understand my shading, B got shaded up, A got shaded down. Yeah, it's region 2 in this case, because like I said, you can kind of see where the yellow and black marker overlap. So my region that overlaps is right here. So that's region 2. And if you remember, these lines are parallel. That's why I'm getting this kind of funny situation. All right. All right, one last one. I'd always like to throw in a little bit of a funnier looking one. This is actually an easy one, but it looks different, so it could be confusing to some people. These are equations of a line, all right? So the first one, where do you think that's going to get graphed? Well, we've done one like that where y is just 4, right? Remember, I said in a table, doesn't matter what my x values are, y is always 4. So where is y always 4? Right here, and that's a dotted line. So now I'm still going to test a point. Is 0 less than 4? That's true, so I'm going to shade down. And I can do this one right here. In this case, x is always -2. So no matter what value I plug in for y, x is -2, x is -2, x is -2, and so forth. Again, dotted line. I'm going to test the point 0. 0 greater than -2. That is true, so it's going to get shaded this way. So my solution is this region. And just to kind of distinguish the difference between the two, kind of like that Rwanda problem, in this case, these are dotted, so my solutions aren't on the line itself. So none of these points on those lines will work. So -2, 4 will not work. Whereas this case, this intersection point works because these are solid lines, meaning my solutions sit on the line as well. All right? If you have any questions, please feel free to ask.